Welcome to the AI in Manufacturing podcast here on Industry4.tv. I'm your host, Kudzai Manditereza, and today we'll be discussing connectivity as an enabler for AI, and we're going to discuss possible use cases in manufacturing. And to help me unpack this topic, I'm joined by Bernd Hafenrichter, who is the CTO of Sofico. Welcome to the show, Bernd. Thank you so much for joining us today.
Yeah, thanks a lot for the invitation. It's a pleasure for me to be here with you and to discuss this interesting topic.
Awesome. I mean, you've shared an interesting history of Sofico with me just offline a few minutes ago. So could you maybe for our audience just briefly introduce yourself, who you are, and then kind of like tell us a story behind Sofico.
Yeah, I will. So, yeah, as you told, my name is Bernd Hafenrichter, and I say in my chest I have two hearts. One heart belongs to Sofico, where I'm responsible for the implementation and all the technical stuff around our connectivity product Orchestra. Orchestra is in earlier days you would have said it is an EAI software. Maybe in between, we would have said it is an integration service bus, and now we use it for connectivity in manufacturing. And I was responsible as architect and developer for creating this piece of software. And parallel to my work at Sofico, I'm working as a professor in the Technical University of Ingolstadt, where I'm doing teaching for software engineering, for software architecture, for software project management. And what I like at this combination is that I can combine my real industrial experience with the theoretical experience that I teach my students in class. And what I try to do is I want to teach the theoretical things to my students, which I know that work in the real world. And on the other side, if I'm doing architecture and working on our product Orchestra, I want to have a solid theoretical foundation for the things that I'm doing there. And as you can see, that's a perfect combination because both sides can benefit from it. And as I explained to you before, I think 40 or 50 years ago, we started with the implementation or with the first steps of in creating our software product Orchestra. And Orchestra really is can be seen as a connectivity layer where you can connect different systems with different protocols and ensure that the data, that the information is transported between the different systems. And over the time, let's say our product, our architecture also had to evolve because we have seen new technologies like microservices. We have seen new technologies like edge cloud fog computing. So our orchestra, the basis for our orchestra is a very flexible architecture, which allowed us to adapt the software over the time to the different needs. And that is what we do when we talk about software development and software engineering. What we do permanently, we have to adopt our software to our customers' need. And especially when it comes to the manufacturing when it comes to manufacturing, it's really, really interesting because here we see a lot of heterogeneous systems. We see legacy systems, for example, legacy ERP systems. So greenfield or IT, or we also see brownfield IT systems, which run legacy communication protocols, for example. And when we think of connectivity, and when we think how nowadays manufacturing is thought, then we say we need information from top, from the ERP system down to the machines which are doing serial production. And we try to establish this connectivity with our product Orchestra. So Orchestra has built-in protocols for example, S7, Modbus, and so on. So typical industrial protocols. And what we do, we act as a transformer, we act as an adapter, which adjusts the information so that everybody in the enterprise, so every system in the enterprise can participate from this data depending on the need of the customer. Yeah.
Awesome stuff. Thank you. Thank you so much for such a fascinating background, information. Now, when we, as you may know, a lot of manufacturers are really are going through these fairs where really they're adopting artificial intelligence use cases for their manufacturing plants. So when we talk about the idea of connectivity as enabler for AI, what do we mean? Can you explain this importance in the context of digital transformation in manufacturing?
Okay. Yes. So I think the challenge when we look at so at this manufacturing area is that we have a lot of information available, but not in a sense that the information can be put together and we can apply AI to this information. Let's say more or less we have silos which each of the silos has the information, but we do not bring them together. And therefore, in my opinion, if you want to do AI and you want to do AI on all the data that you have, your production data, sensor data, everything which is generated during a production process, you need to bring all this information together. And if you want to do that, the first step which you have to do is you have to solve the connectivity issue, because without connectivity, you cannot use your data. And that's really the first step. And even if this maybe is classical informatic, like dealing with protocols, data transformation, and so on, it's very, very important, because what I have seen and learned in the past is that this big amount of heterogeneous systems that we see there is not easy connected by just one adapter. So it depends really what machines is your customer using, what maybe operating systems on industrial PCs are used to control the machines, what type of PLCs are used to control the machines. And depending on that, you have a real, let's say, a bunch of languages, protocols, data models which do not fit together. And because it's like you have 10 people and every one of them is speaking a different language and has a different understanding of the ideas they are talking about. And therefore, it's the first step is to establish the connectivity. And in the second step, when we have established the connectivity, maybe you can do a kind of a normalization of the data. For example, people talk about a unified namespace where all the information of a company comes together. And when you have this information available, then you can start doing AI, because as a basis, what you need is you need the data. And in years ago, I had a discussion with people not in the manufacturing sector, but in the healthcare sector. And we talked not about AI, we talked about scalable databases. And I asked them, why do you think about scalable databases? Why it is so important for you? And they told me, listen, we know that we have to collect data now. We do not know the questions that we want to answer with AI or other technology in the future. But we know if we do not start collecting the data, we won't never be possible to have a benefit from this data. And so the first step also here was collecting the data, putting them in a kind of a data lake, for example, and make them available for the future questions which you may answer with AI. And I think based on that fact that the information that we generate is really important, and maybe even if it's only a small piece of information and you do not have the idea why you use it now, maybe it may be the missing link. If you ask in 5 or 10 years, how do I have to adopt some values in my production process to reduce the number of products which are a defect during my production? And maybe it's exactly this sensor value which you do not have collected, which measures pressure, temperature, and so on, which gives you the information. And I think that's the reason why connectivity is really important as a first step. And only if you can have this connectivity issue solved in a way that all the data can be collected, stored, and used for later applications of AI, then you are in a good starting position for the questions you want to solve in the future. And I think the applications that we can do with AI is a really wide range. I discussed use cases, for example, with people who said, I have a lot of experienced workers, but if they want to know, could you train your experience or give your experience to new colleagues? And they said, no, it's like a feeling. And I could not exactly tell why I, for example, do it this way. It's just a feeling I learned over the years. And maybe also such a feeling could be learned by data we collect. And therefore, we could improve the production processes of the customers. That were ideas we discussed with customers. And again, also here, the basis for that all is we need a better understanding, which means we need the information, we need the data that we can collect, and we need to store them for using them in the future. Yeah.
Awesome stuff. Yeah, so I mean, from the way I understand it, really, as you explained it, that you've got this manufacturing environment that has got different siloed information. And so connectivity as an enabler is really about setting up that pipeline that allows you to get the data out from the machines, normalize it, contextualize it, and then put it in a data lake or somewhere where it can then be acted on. So my next question to you is, having dealt with customers or generally in your company, what have you seen as the biggest challenges to this approach of OT IT integration, trying to bring all of this data together?
That is a good question because I think every customer, every project has its own challenges. When we look to typical manufacturing situation, you may see systems which have, let's say, standard connectivity, even if it may be a legacy protocol. I saw systems which have been completely developed where we see a software solution which was developed by the customer itself, for example. So no standard, no proprietary implementation where you could not use any standard connectivity. And that's really the first step that you have to solve. Since we have, let's say, legacy machines, legacy systems, which have been developed over the years by themselves, you first of all have to get an overview over the machines, over the IT systems, everything which is necessary. And when you have achieved this overview, and then you can first of all think in terms of connectivity, how do I can do the connectivity? And the next level is then you come to, let's say, an enterprise level of architecture. What can we do with this data? How do we have to set up our enterprise architecture? How should we set up the whole system? And another challenge, for example, especially when you are in this production area, even it's only connectivity, you have non-functional requirements like robustness, scalability, security. And these things are really, really interesting because as in the perspective from a software company, it's a really also a challenge to implement software in a way that you have really robustness, high availability, and everything you need in this area. And that are the typical challenges. Also the question, what will be the overall architecture? How could we set up our enterprise architecture here? Do we have to use centralized systems, for example, or do we utilize more a microservice architecture? That are open questions. And in my opinion, there is not one architecture or one type of architecture which fits all. You have requirements, and based on the requirements, you have to find the perfect architecture for your customer. Because in my understanding, even if you, for example, have the idea of a microservice architecture with a connectivity layer and, for example, a broker which is used for communication between the different integration services, for example, it's a way how you can structure your architecture, but if it's best for your customer, it really depends on the customer needs. And for example, the next question is, what is with data which are more streaming data, for example, with a high frequency, but a small width, for example. On the other hand, we see situations where we have files which have a size of a gigabyte or more, for example. So the challenge is really to deal with these heterogeneous systems. The next challenge is to find the right architecture so that it fits to the needs, so that this architecture can be managed also by the IT people at the customer's company. And that is always what I see, what's really interesting, because the solution which may fit perfect for one customer may totally be wrong for another customer because of the different needs, maybe also distribution aspects, like have you different plans or so on, or also security aspects, separation of network layers and so on. So we have a lot of different aspects here, which let's say is interesting if you are allowed to solve such a problem for your customers.
Interesting. So, I mean, I would like to, linger on that kind of like topic a bit and maybe kind of like get more into a bit more technical discussion. Primarily, you mentioned obviously that some, data sources have got no standardized connectivity interface, obviously, which makes it difficult. So, I want to kind of like get your thoughts on what do you see as like the actual protocols that are being used at different levels of the stack or different layers of the stack? Do you have sort of like specific protocols that you say maybe support or favor or generally see as a trend that is being used by manufacturers who have got successful connectivity infrastructure?
I think one of the most popular protocols that we see nowadays is the OPC stack, which is really one of the protocols which we see really a lot. And if it comes to legacy protocols, it is really widespread because we see protocols. I told you before, Modbus, for example. We also PLC protocols of the different PLC vendors. For example, you have protocols like Ethernet IP or ADS from Beckhoff or Siemens S7. So what we see is a bunch of different protocols here to connect with these PLCs. And often people really want to use this legacy protocols because they want to save their investments. They do not want maybe to change the existing infrastructure, because every change is like this interruption, which may lead to other problems. For example, they want to preserve their invests here. And therefore, we have really a bunch of protocols here. And at the end, what I also have seen is really individual protocols which have been developed by the vendors or customers themselves, where we really have to do a deep dive on the byte level or on the deep protocol level. So when we talk about the layering, we start often one layer above the TCP layer. that is our layer where we start, and we really look at Wireshark traces, for example, where we say, okay, we need to understand how this protocol works. And for example, if you want to connect to PLCs, often you get a memory footprint of the PLC. Then you have to discuss with the developer of the PLC, how is your memory layout structured? So we have really, let's say, this very deep technical protocols where you are on this level of bits and bytes. And when it comes, let's say, more to the enterprise level systems, we see these classical protocols like JSON or REST. We also see XML web services, for example. So the typical protocols which are used here. Sometimes we see maybe specific protocols like this RFC protocols used for SAP. So that depends a little bit, but I think this standard what we see is this all these web services, REST, SOAP things, and OPCOA, and maybe where we see what we see nowadays, also protocols which have been built, or let's say not protocols, more specification, which have been built around these protocols, like data spaces, for example, which also use OP. So we see also applications of these protocols in different specification, and also that is interesting for us. But again, here we have a mixture of everything from deep technical to high level protocols, and yeah, that's our daily business.
Awesome. Yeah. And I'm going to put you on the spot here and kind of like ask about your thoughts on if you've kind of like heard about the unified namespace and have, read some stuff around it. What are your, opinions or thoughts on the unified namespace, and where do you see that fitting into that whole stack?
That is that's a good question. I'm not a deep expert in doing in this unified namespace, but let me compare it with approaches I have seen 10, 15, 20 years ago when I started my career as an IT architect. There was one architectural principle very important. It was service-oriented architecture. And a lot of people thought when we do service-oriented architecture,
Yeah.
when we do service-oriented architecture, then we have to have a common data model for the whole company. And finding that common data model for the company maybe become somehow very, very hard, because you have to find a model which can deal with all the different requirements of all different stakeholders, of all different systems, and so on. And therefore, what my experience was here is that not it may be not the best idea to have this common data model, because it is really hard to achieve that situation, and you need really to establish, let's say, a kind of a enterprise architecture management which does the job to you. Maybe it is a better idea to ask the question, what would be really relevant for me, and concentrate on this portion of data which is really relevant, and let the others way systems goes away as it is, without the need to standardize everything. And that is what are my thoughts when I think about this unified namespace. My basic understanding is a unified namespace needs a kind of connectivity. So all the systems need to be connected to the unified namespace. And the next step is, I think, a unified namespace is more a concept and not a product which you can buy from the shelf. And again, when it comes to this data modeling, the question is, how do we have this data normalized in this unified namespace? And maybe it would be a good idea to think of this classical integration patterns which have we seen in the past, where we say, for example, a system which wants to retrieve data, for example, from the unified namespace, maybe the data model of the receiving system does not fit perfectly to the model of the unified namespace. So also here, integration connectivity became a big part. And when I compare it to some bachelor thesis, which I have, which I was a supervisor in the past, we also thought what is a good idea to prepare a data lake, for example. And in my opinion, when it comes to a unified namespace, then it's more or less comparable to a data lake. But also here is the question, how do we store the data in this data lake? Is there a final format, a final data model, or do we store the data in a way that we can query them and prepare them for the real use case that we want to solve in the future? And I think that's a big question here, how you do the data modeling. It's, in my opinion, not a problem of a technical setup. I have seen brokers, I have seen connectivity layers, I have seen databases in a unified namespace tools, which we know a long time. My aspect here is, I think it's a modeling challenge to find the namespace that fits to the company. And in theory, I think that's easy if you have small data models. But in practice, I think that will become really a challenge. And maybe here's the 80% solution would be the perfect solution, because you know this Pareto principle. 80% could be achieved by paying 20% of money. And the last 20% of my solution will cost me 80% because they are hard to solve. And the question is, do we have to build 100% perfect solutions, or is it okay to have the one which is cost efficient and helps us most of the time?
Yeah, absolutely. Yeah, so I mean, in my experience over the past, few years, what I've seen is that there's a lot of uh, confusion, as it were. Obviously, there's a lot of information that is, coming out from different vendors wanting to sell their solutions. So there's a lot of misinformation, if you will, for manufacturers that are looking to find the right solutions to their problems. So I want to kind of like get your thoughts in your view. What are some of the biggest misconceptions about, the implementation of connectivity solutions have you seen out there to help some of the manufacturer leaders that may be listening on this call?
Okay. Yeah, also here's the question is, as I told you before, there is not a solution that fits to all of the manufacturers. I think there are really different approaches, and it starts from the technical infrastructure, where we see companies that use Docker. On the other hand, we see companies that use industrial PCs using Windows. So that is really completely different. And in my opinion, I'm not a friend of, let's say, I'm a friend of quick wins is not the best word for it, but the question is, when you try to establish, for example, an AI use case in your company, and you need to implement a big unified namespace or enterprise architecture, data lake, whatever, with connectivity, that will cost you a lot of money. And the question is, what will be the benefit for me? And I'm a friend of, I do not know, maybe you have heard about a concept which was called Quasar Enterprise. It is also a concept from service-oriented architectures, and they talked about a lighthouse. You should have in mind how your perfect architecture should look like, but you should not start implementing and doing everything to reach it in the first step. The idea is make small projects, have the lighthouse in mind, have your ideal architecture in mind, so that you do not implement things totally wrong. And with the small projects, you can show the benefits to your stakeholders. You can see if your concepts work as expected. And if your concepts do not work as expected, you are early, you can change your architecture, you can adapt your ideas while you are working on them. And that is what I'm really a friend of it. The idea, the misconception for me would be to have a big project that changes everything without any prototyping, without any check if all the ideas would work as expected. And for me, that would be the biggest misconception. And my idea is really to have small projects that show that the ideas are successful. And if you start with AI also here, we have to get an idea, we have to get a feeling how AI can help us here. And if you talk to your people in your different departments, maybe you will get ideas where we can improve their daily work. And when we have some nice use cases which we can implement in as a short, small project, then we can show our stakeholders that IT is not only fun for the people who are doing it, it's also a benefit because people can do their work more efficiently, for example. That would be, for me, the best approach. Or on the opposite, for me, it would be a misconception where you would say everything will be perfect, but I will see it in 5 years when the work is done. That has never worked in my experience.
Yep, absolutely. So maybe just to linger on that quickly, how do you how then do companies ensure scalability out of that small project? So because when I was reading one of the reports, many reports actually on AI implementation in manufacturing, I think there was a big number. I think it was around 70% of an AI in manufacturing pilots were stuck in that phase. So they proved the concept, but they just got stuck there. They couldn't scale it out to the entire company. How should they ensure that they have it in such a way that it's scalable? Scaling, the connectivity aspect of it, right? Scaling that idea of, so we spoke about this idea of connecting to machines, normalizing, contextualizing the data, and then ending up in an AI use case. And if it's a process that needs to be repeated every time for every
Okay.
machine, then it becomes difficult. How should that be handled?
So first of all, when you start creating such an architecture, I think first of all that you have typical problems to solve, which lay in this area of connectivity. And what we can recommend here is thinking of a interface factory or a solution factory where typical, let's say, connectivity use cases are pre-implemented for you, and you just have to roll out them for your different machines. That would be a real benefit in having a scalability here, because you do not have to reinvent yourself by every new machine you want to connect to your core ecosystem. And what I can recommend here is, normally there are a lot of principles, methodologies, patterns, which we know nowadays how we can we structure connectivity solutions. And normally, in my experience, you should have an architect, for example, that has a vision which is based on sound, on a really sound and solid architecture, on solid principles. And because all the principles which I know from my teaching and from my projects, I have to say it, even if it's simple, it's loosely coupling and high cohesion. And if you think systems in such a way that you try to have a loosely coupling when possible, you improve your flexibility. When you have a loosely coupling and combine it with abstraction, maybe you can have an architecture where you easily can connect new systems to your ecosystem without reinventing everything self. So for me, in the first step, it's really a question of architecture, where we define it in a way that it becomes flexible. And now, when you say connectivity, I want to make connectivity scalable. The question is, how can we make it more efficient? How can we bring efficiency in this process of doing the connectivity? One approach would be standardization, but also here, even if we create new standards, normally also if we have new standards, say they depend on the requirements of the people who did the standard. So a standard would not solve everything, in my opinion. And but what we can do is we can think in kind of templates. Do we have reusable tasks in our company where we can have solutions which may be adopted easily to new situations, and then we can get scalability in it. And nowadays, and also scalability is not only to scale it to new manufacturing plants. Also, the question is, how do we have to set up the IT infrastructure at the back end that we have scalability, for example. So also this is, I think, a widespread area, but I think using principles that we know from that evolved over time, and that we know that the principles do really a solid work. I'm a friend of using such principles, defining an architecture with this lighthouse, which is ideal architecture in mind. And what my experience is not to test really early all the non-functional things which can occur, like data rates, robustness, and so on, even if I only do a small step. And now when I have learned this, let's say, all these things, and I manage to have a kind of an interface factory, which may be AI driven, for example, where you can say, okay, I want to connect a S7 machine. I did, and you can tell your AI, okay, there is a machine, it's a S7 machine, and so on. And the AI can, for example, can set up the code for you, or the coding which is necessary to do the protocol stuff. Then you also have an easier scalability in setting up the connectivity, and also that's an idea which we as Sofico are following. So we really try to make connectivity for our customers easy. And what we did in the past, we call it AI assistant. And first of all, you can tell the AI assistant, hey, I want to implement connectivity to an OPC08 channel, and I want to store the data in a database, and it creates a first draft of a solution. But here we are not at the end, because when it comes to data models and to protocols and so on, we need much more information. And when it is possible, for example, to give a protocol specification to such an AI assistant, and it will create automatically the connectivity layer for you, that's perfect. Because in my experience, also, if it's only technique that we have to solve, for a lot of people, it's really hard to go down that deep in the technique to find a protocol solution. And so we are thinking of automating all the stuff with AI. And when you combine that, let's say you say you have a kind of predefined templates which could be adjusted by additional information, and AI could help you to adapt it to your requirements, and then you have an easy deployment. So that would be perfect, I think. And then you have this scalable effect here.
Absolutely. Yeah, I think we've done a great job of really laying down the problems and opportunities for enabling AI with connectivity. What I want us to do now is to now, focus more on what Sofico is doing to address all of these challenges that we've been talking about.
Mm.
So maybe if we can, first of all, kind of like start by understanding your value proposition as Sofico, and then from there we go on into your Orchestra platform
Okay.
and break it down into all its components.
Okay. Yes, let's say our proposition is connectivity as a no-brainer, which means we know that connectivity is somehow a kind of a repeatable task, and we want to make it so easy for our customers that it's really a no-brainer to set up the connectivity to your machines, to your greenfield, brownfield, IT, and so on. And that is what we want to do. And we are setting up a kind of a, let's say, interface factory or also interface shop where we provide solutions to our customers for standardized use cases that we see at our customer sites.
Awesome. All right. You've got different products. I think you've got Orchestra OT, Orchestra IT, and Orchestra Edge, right? So I think these are different component. Are these different components of one product, or are they different products? Can you please kind of like break those down your Orchestra platform?
Yeah, okay. So Orchestra is our main product, and the main job of Orchestra is doing the connectivity, translating data, transporting data, and everything which is needed to implement, let's say, connectivity solutions. Orchestra has a rich set, we call it channels of adapters which speak different protocols, which speak different formats, and so on. And Orchestra itself is a low-code platform where you can define your connectivity by in a web designer on basis of a drag and drop solution, or on basis of this AI assistant, which creates the models automatically on basis of the specification for you. So we are a low-code platform, and when you compare it, what are typical components that this low-code platform has? We have components for doing data transformation. We have a component for defining the integration logic. We have a component for connectivity. So we have a monitoring component. So a lot of different components which together form the whole product. And you said we have Orchestra OT and IT. At the end, it's a kind of setup of how our orchestra as a product is installed. It's a customer side. Our orchestra can be implemented as an edge solution, for example. It can be implemented as a fog solution. And what we have the ability to customize our software in a way that it fits perfect to the use case, to the situation where it is used. When we execute it on a small, let's say, edge device, we have a low footprint, for example. We have a tooling in our software, or we are working on a tooling. So we are following this DevOps cycle also in integration. We say when you set up a solution, it must be easily possible to test your connectivity solution. Also, that is let's say a big challenge in when you do connectivity. How can you test your connectivity solution compared to what we see in software engineering, unit testing, integration and testing, and so on? And we have seen sometimes it is hard to have a test system which you can use for testing. So we have a test suite for our software where we can do system mocking and so on, and easily have a test suite. And the idea is when you define a connectivity solution or modify it, you can execute your test cases against it. When all the lights are green, we have a prototype for a component which we locate in this area of microservices. This component analyzes the configuration and prepares, let's say, an execution environment for you, which is shrinked to its minimum. It only contains the component you select, so the components which are necessary to do the connectivity. You can decide if you want to have a monitoring interface or not, or if you only want to so we have a kind of a shrinker. So we try to have integration services which exactly fits to your needs. And this service then can be installed to your edge device. It can be run as a Docker container, for example. But here's the idea is it's really small sized. And typically in such an area, when it comes to connectivity in this manufacturing area, we have a highly distributed systems where we have really different orchestra installed on the edge level. And if it comes to communication to the greenfield IT or to the ERP system, normally we have a kind of a centralized system that does all the communication, and the edge devices and our orchestras then are connected by a broker, for example. We also have a kind of a built-in broker technology, but we are free to use a standard broker or our own set. That depends. But we have a distributed architecture, and when it comes to this, let's say, central orchestra, which does the communication to the greenfield IT, it's a much more bigger system which can be installed in a clustered fashion or also as a distributed microservice architecture. So we have, let's say, a software which is highly flexible and adoptable. And that's the idea here, that we use this low-code modeling platform to do the job, and that we have the right infrastructure to execute it as it is expected. And the real challenge here is that integration means 100%, or connectivity means 100% of your time the software is running in the background. Nobody sees that your software is existing and doing the job, but they feel that something is going wrong when there is a failure. And so one of our important goals was to make it as robust as possible, to allow a perfect monitoring of the software, to have alarming within, so that you have really the chance to do an operations of the system which is high available and without big where we have really a high available setup, a robust setup, and that is the ecosystem of our orchestra. We have the central product, and we build a lot of, let's say, other products around the software, and we follow this DevOps cycle where we try to have this interface factory where we have a component, the solution hub, which allows us templating of connectivity solutions and to roll them out and adapt them so that it becomes scalable. And that are all components that we developed over the time, and where we have seen that customers need it. And nowadays we are really working on this AI support in our software. We are working on, let's say, this DevOps cycle to make deployments easier and so on. So we follow the principles that people see nowadays also in typical, let's say, architectures like microservices, DevOps, and CICD. We try to bring everything in our product.
Oh yeah, absolutely. I think there's been a massive adoption of more IT architectural approaches, like your microservices, event-driven architecture, and things like that.
Yeah.
Yeah. So I realize we're running out of time here. So just quickly to get your thoughts on did you have maybe one or two case studies or success stories that you could share just to make it all concrete, where customers have used your Orchestra platform to set up the connectivity?
We have a lot of different use cases where customers used our Orchestra and say successfully. used Orchestra to implement the connectivity. I'm just thinking about which is the one which I could explain to you at the best. Yeah, one use case was there was really this connectivity problem where a customer had to connect a machine that had implemented a user-defined protocol and everything, and we had to customize our software in the way that the customer can easily connect to his machine. That was one successful use case where we did, but also in our interface factory where we do scalability, we have customers that use our platform to connect their own customers. And for all the customers, there was the question, what are the typical systems of our customers? For all the typical systems, they create standard templates. And now when we do a onboarding, it's a matter of 5 or 10 minutes, maybe an hour, until a new customer could be onboarded, because we only have to adjust the template, to deploy it to a runtime, and then the connectivity works. That are typical aspects we did. As you see, we focus mainly on connectivity, and nowadays, based on, for example, research projects, we also look how can we use AI in such solutions. Maybe how can we feed information or send information to AI systems? But that is currently research. Maybe we can talk in a year and I can tell you more about that things.
Awesome stuff. Bernd, thank you so much. This has been such a fascinating conversation. I would like to give you the opportunity for a few last words if you've got anything that you want to say to our audience.
Okay, thank you very much for having the chance for the interview with you, Kudzai. It was very, very interesting for me. And if you feel free, if you want to discuss solutions in this connectivity area, to contact me or to contact Sofico. We are the experts in doing connectivity. Connectivity is a no-brainer, is our mission. And together with you and our customers, I think we will follow this mission and make it really that easy. Thanks a lot.
Awesome.